Thank you so much for joining us. Today we have Joe Jones, who's the CTO of Harvest Automation, formerly of iRobot, and the inventor of the Roomba. And he's going to join us today and answer a few questions. So thank you so much for coming.
Oh, my pleasure.
Cool. So I guess we'll get right into it. You had originally started at MIT. Can you tell us a bit about your work in the AI lab and how the transition was from academia to industry at iRobot?
Well, I started at the Artificial Intelligence Lab at MIT in, I think it was 1982. And when I was there, I was on the research staff. And it was a really exciting place to be. I had majored in physics and had sort of stumbled into robotics. But once I was there, I discovered my true calling. It's robots rather than physics. And there's all sorts of exciting things going on at the lab, all sorts of really smart people doing really interesting work. And it convinced me that within, maybe 3 to 5 years, we were going to have robots all over the place and they were going to be doing all sorts of wonderful things. But then that didn't happen. I was at the AI lab for a total of about 9 years, and it didn't really seem to me like robots were much farther along when I left than when I had started. So after I left the AI lab, I started working at iRobot, which in those days was called IS Robotics. This was long ago. And what we were trying to do was to build practical robots to do practical things. In the early days, iRobot didn't have the money to fund their own development projects, so they were doing sort of one-of-a-kind projects for research organizations, and they were trying to build research robots. And it took from about 1991 until 1999 until iRobot was on a sound enough footing that they could develop a product of their own. And it was about that time that I and a mechanical engineer proposed that the company develop Roomba. So the ideas behind Roomba was that the reason that robots had failed all those years was because people had not treated robots as if they were products. They had thought of themselves as, inventing the future, and that the robots that they would build were so wonderful that they didn't really have to do anything. They just, everybody would appreciate how wonderful the robots were. And of course that didn't happen, right? There was sort of failure after failure after failure of robots that were supposedly designed for the marketplace. So when we developed Roomba, we wanted to be very well grounded in it had to do something that people wanted done. You had to be able to build it with the technology that was available at the time, and once it was built, you had to be able to sell it for a price that was comparable to what people were paying for to solve that problem at the time. So there's been other groups that had tried to build. Electrolux was offering a vacuum cleaner, robotic vacuum cleaner that was $1,400. Wow. But you don't have to pay. Everybody knows you don't have to pay $1,400 to get a device that will clean your floor. So our idea with Roomba was that we wanted to offer a device that was comparable to what you could buy in a store, but it had this extra feature that it cleaned the floor for you and you didn't have to do it. So that was sort of so we took our ideas from academia and all, and basically applied them to a product. And the key was that we treated Roomba like a product rather than like a robot.
That's great. So how do you think that compares to, now iRobot was also build government robots, right? Defense, military types of things. What are some of the differences you've seen for the consumer market versus building for the military market?
Well, the biggest difference is the price. If you're building a robot that's supposed to save the lives of troops, you can pay whatever you want, right? You can charge, rather, if you're building the robot, you can charge whatever you want. And the military has all of these many constraints, specs that you have to meet, and meeting all those specs makes the price really high. So if you're developing something for military applications, you can spend $100,000, $200,000 for your robot, and that's fine as long as it does what it's supposed to do, and it lasts out in the battlefield, and it uses certain batteries that it's supposed to use, and so on. But when you're building something for the consumer market, you have a fight over spending 5 cents on a transistor. It's really critical to keep the price low, because if you don't keep the price low, nobody will buy it. So the solutions that you come up with for military devices versus consumer devices tend to be qualitatively different, which means that if you start off on the military side, although people argue that you can do it, I have rarely seen it happen that you can start with something which is really expensive and then cost reduce it down to a place where a consumer would pay for it. So you end up having sort of different kinds of solutions on the military side versus the consumer side.
I imagine that must be really tough. So I'm wondering actually about some of the challenges you faced at iRobot and why you ultimately decided to leave and start your own company or help found Harvest Automation.
Well, starting in the early days at iRobot, we always thought that if we just had a success, if we just had some product that was bringing the money in, then we would be able to start exploring all sorts of other places where robots could be useful. And then Roomba became a success and PackBot became a success at about the same time. And instead of having more freedom, it turned out we had much less. Because after the company has had a success in those ways, what they want to do is to sort of extend that success. They want to do something that's predictable. So once you've got a market and you've got the channels that sell into that market established, it makes it easy to build another product. So you can have a good estimate of what kind of return you're going to get on the money that you invest in a product. Whereas what we wanted to do was to say, well, there's this market that might work or it might not, and there's this other market that might work, so let's spend lots and lots of money on that and maybe we'll get something back. And that didn't fly. So the only way that I thought that I could get to the next big thing in robotics was to leave iRobot and start a startup.
Great. And how did you take a look at different markets for Harvest Automation? Like, what did you consider before you set on?
Well, when we left iRobot, we didn't have any idea what kind of robot we were going to build. So we spent the first few months of the new company basically looking around for opportunities. And the ways that we did that was just brainstorming among ourselves. We did site visits. One of us went to an alternative energy fair. I and another guy went to a food distribution warehouse. And finally, we found a local trade show that happened to be related to agriculture. We were kind of looking for, maybe there's something in agriculture, we thought. So we went to this trade show, and it was there that we found this application for moving potted plants around that we had never heard of before. It had no idea that such a thing even existed, but it turned out to be perfect for the kind of robot that we wanted to build.
Wow, that's great. What were some of the sort of lean startup challenges that you faced? It sounds like you did a lot of customer discovery before you lit on the right thing. Yeah, I'm wondering if there were specific failures from which you learned along the way, or.
Yes, we learned. We learned many interesting lessons in trying to develop the product. One of the ones that I found kind of interesting was, when we started off, we thought that investors would be skeptical of the market and of our ability to build a product that would do what we said it was going to do. So we put our own money into the company before we started going to investors. We put our own money into the company. We got a little bit of funding from friends and family, and we spent about a year developing this device to demonstrate what we were talking about. It wasn't ready for production or anything, but you could see that the robot would move around and it would pick up a potted plant and then put it down. And right at the time that we had finished our prototype and were ready to start looking for funding, that was when the economy went south. So it was like 2008 that we started looking. So it took us a year longer to get funding than we thought it would. And then we discovered, when we actually were talking to the VCs, that nobody challenged the idea that we could technically build the thing that we said we could build. So we probably didn't really have to build that prototype robot in the first place. We might have just been able to go to the market with, go to the VCs with that idea,
wow.
And it would have made funding quicker and saved ourselves a lot of pain, but we didn't know that.
It's okay. Lessons learned.
Yep.
And you know, for the benefit of anybody watching this, can you just tell us exactly what the Harvest Automation robot does and is for?
Sure. The robot that we built, called the HV100, is designed to move around container-grown plants at nursery farms and at greenhouses. Not a lot of people know that this needs to be done, but in fact it's a major step in the production of ornamental plants. And what you have to do is, the plants are typically started in the greenhouse when the seedling is planted in a pot. Then the pots are all brought together on a wagon out to a growing bed. The pots are typically all put on the ground at once, maybe by a forklift or by other means. And then, if you left them that way, the plants would start to grow, and eventually they would grow into each other, and they would damage each other, and then you couldn't sell them. So all the commercial growers do this step called spacing, where they take the plants which were set on the ground close together, and they move them apart. Now, it doesn't sound like much, but it takes an army of people to do this. So what our robot does is they take over that task, and it turns out we adopted this task basically for technological reasons, because we thought that the robot could do it. But then it turns out that finding people who are willing to do this job is a big challenge for growers. There's a lot of turnover. Sometimes they can't get the people that they need, at least in certain parts of the country. It's just really hard to get the people. So the robots solve a real problem.
That's great. Thank you. Are you looking to expand into any areas in the future?
Oh, you bet.
Great.
Right. We want to build another product or two for the nursery and greenhouse market, but we see lots of applications in agriculture for robots. There's a lot of labor that goes on in agriculture, and it always seems to be hard to get people to find enough workers to do the job. So it seems like the opportunities are really ripe for robots.
Okay. Do you think that would enhance food security throughout the world also?
We think that the robots can be used to improve the yield of crops. There's a UN study saying that during the next 40 years or so, we have just to keep up with increased demand, we have to increase food production by about 70%. But the catch is that we don't get to use any more land or any more water than we're using for agriculture right now. So that's a big challenge. One of the ways that you could do it is by lavishing attention on plants. And you see that in a county fair. You go there and you see those giant vegetables.
Sure.
And it wasn't because the farmers used some magical seeds that aren't available to commercial growers. Instead, they were able to get the yield and the quality by constantly paying attention to their plants and, how well is it growing, and giving it everything that it needs right when it needs it, and pulling all the weeds. And on a commercial scale, there's just not enough people to do that. So you can't increase the yield by throwing more people at the problem. But you could increase the yield and the quality by using robots to do some of that labor.
Great. Fantastic. Well, I'm excited to see how all of this turns out, hopefully in the coming years, increasing food production. So I think that's probably about the time limit that we have.
Okay.
So I want to thank you very much, Joe, for being with us today, and I'm really excited to learn more.
Sure.
Thank you.
Thank you.
Thanks.